next thing we are discussing is using a matrix to solve a system of equations. We have been using substitution and elimination. But when I added 3 equations, what happened to the elimination method?
Oh, it got sticky.
It got sticky. It got a lot longer, right? We went from just 1 elimination to 3, at least, right off the bat, right? And so what do you think would happen if I put 4 equations in there? It's going to be really, really long and tedious. So, elimination, while it's really good and really fast for 2, and it's not even horrible for 3, if you had more than 3 equations, it becomes very, very, very time consuming. And there's a high probability of a mistake. You know, the longer the problem is, the more likely it is that you drop a negative or add something incorrectly, and so one little mistake will throw off the entire problem. That's where matrices come in. So if you just have 1 or 2 or 3 equations, this may not seem like a better method, but what happens is when you add more equations, this method really doesn't get longer, whereas elimination gets very, very long and tedious. Okay, so it has its place, but I'm not going to give you 5 equations to solve when I'm trying to teach you the method. Does that make sense? So it may seem silly if I'm only giving you 2 equations, this is longer, but there's a trade-off. Okay, if I were to give you a lot of equations, this is a much, much faster method. So first of all, you guys don't have a lot of experience with matrices. Have you ever done anything with a matrix? No. Okay, so we are going to start basic. Most of today we're just talking about what a matrix is, how do we use it, that kind of thing. So we won't get into a lot of the solving stuff today. So when I'm talking about a matrix, a matrix is just a rectangular array of numbers. Okay, it's used anytime you have a lot of data that you need to store. So not just in math and computer science and programming, those kinds of things, you have a lot of data. And so this is a way that you can track it. So you have square brackets and then just sets of numbers. The numbers can be anything that just looks something like that. So in a matrix, you don't have any variables, you just have numbers. And these numbers are set up in rows and columns. When I talk about an element, each of these numbers is an element. Okay, so if I talked about that matrix I just created, how many elements are there? 8 total. When I talk about an augmented matrix, it is a matrix with an equal sign. Or in other words, it's formed from systems of equations. So in this section, when we talk about a matrix, we will be looking at augmented matrix because we are looking at systems and putting them into a matrix. In a matrix, to show an equal sign, you actually just do a vertical bar. So this vertical bar is the equal. when I talk about the size of a matrix, you will do rows by columns. So you always list the rows first. So for instance, this matrix right here, the size, how many rows are there? Rows are
Rows go right.
horizontal, just like in Google Sheets or Excel, anything like that. So there's 2 rows, how many columns? 3. So this is a 2 by 3 matrix. What's this one?
2 by 4.
2 by 4 matrix. So you always have to list rows first. All right. So I'm just going to put a matrix up here and talk about a few things. So using this matrix, what is the size? 3 by 4. Your rows are your horizontal, columns are the vertical. Okay. If I asked for the element in, let's say, row 3, column 2. So, row 3, bottom row, column 2, that would be a 0. Everybody see that? So if I said, what is in row 1, column 4? Row 1 is the first row, the 4th column is a 10. If I said row 2, column 3, second row, 3rd column is a 1. So I can talk about a specific element in the matrix, then I can use the row and column to tell you where I'm looking at. Is that okay with everybody? We are going to use these to solve our systems. So what we'll do is take a system and put it into an augmented matrix. So when you have an augmented matrix, each row represents an equation. And it's basically taking the equations and writing them without the variables. So each row is an equation. You don't necessarily have to. We're going to do some examples of it in a second. So each row represents an equation. Each column represents let's just say a variable. So what does my first column represent here? Those are the coefficients of all the x's. The second column is the coefficients of all the y's. The third column is the z's. What's the vertical bar mean? The equal. And then this is the constant. Okay, so when you put them in a matrix, it's very important that you line things up. What do you think I would do if I didn't have an x for one of these? You would have to put a 0 in. So each equation gets its own row, and we line up the variables in our column. Okay? Go alphabetical, just like if you were writing an order of hair or something.
So is this kind of like a, what was that one with synthetic
Synthetic division, kind of, when you leave off all the variables and just put things in their place, yeah. So first thing we're going to do is I'm going to give you a matrix, or excuse me, a system, and we're going to write the matrix that matches it. So when I say an augmented matrix, that means we're going to have an equal sign. Matrix gets square brackets. So when I set this up, how many rows will I have? Two. How many columns? Three. Okay, so my first one would be what? 3, -4, and then because of the equal sign, I'm going to do a vertical bar that goes the entire length of my matrix, and then the -6. Alright, second one would be 2. What's the size of that matrix? 2 by 3. Good. Okay. Second one. Look at that carefully before you try to write your matrix. What do you notice? Yeah, everything's equal to a 0, but then when you look at this side, do they all have x, y, and z? No. We have to set this up carefully when you are doing the matrix. So the first one we can handle. What's my first row going to be? Okay. My x was 2, my y was -1, my z was 1, equal, and my constant was 0. But the second equation, what's my x? What's my y?
0.
What's my z? Okay, then I need it to be equal to the constant, so you have to think about adding that 1 over, so it equals 1. So you may have to rewrite your equations to move your constant to the other side. So my last equation would be, or my last row would be what?
1, 2, 0.
Because you have to think about adding that over, the 8 over, and we didn't have a z. Okay, you guys try the next one on your own. So just take a second and write the matrix for me. So in an augmented matrix, the constant has to be on the side of the equal sign by itself. So my equations are basically 2x plus 3y equals 6, and 4x minus 6y equals -2. Since the only variables I have are x and y, you only have to have columns for x and y. So this would be 2, 3 equals 6, 4, -6 equals -2. Alright. Let's go the other way. I'm going to put 2 matrices up here, and I want you guys to write the system of equations that would match that. Okay? So see if you can try these on your own. These are the matrices. Write the system of equations. So this is like my x, my y equals in a constant. So 5x plus 2y equals 13, and -3x plus y equals -10. If you brought those constants over and said it equal to 0, that's equivalent. You just don't have to. All right, for b, what's my first equation?
3x minus 1x equals.
Second equation. There's no y on that one. And the last one? Okay. So, do you guys understand what a matrix is? And how to go back and forth between a matrix and a system? Would you want to tell me? So I want to start talking about how we use a matrix to solve a system. It's kind of like doing elimination, okay, except we don't keep the variables in there. So think about what you do when you eliminate. You usually start out multiplying by something, right? So it's going to be legal to multiply the whole row by something. And then what do we do after we multiply? Yeah, we add them together to get a variable cancel. So it's going to be legal to add these rows together. So this is called the Gauss-Jordan method. It's how you use a matrix to solve it. But first, I just want to specify the legal things that we can do. The matrix operations, things you can do that will not change the solution. The first one, you can swap the rows. When you're solving a system, does it matter which equation's on top? No. So if you need to flip 2 rows, you can. Second legal thing is you can multiply by any non-zero number. Okay, when we do elimination, we can't just multiply the whole equation by 0, but you can multiply by anything else you chose. Positives, negatives, fractions, decimals, whatever, it's legal to multiply, I should say multiply a row. We'll do the whole row because a row would represent an equation. The third legal move would be to add rows together. Because when we do elimination, we multiply by something and then we add those two. So these are the steps that we will use to solve our matrices. First, I just want to talk about how these will be written so we know what the row operation is. So notation, you'll have a matrix and it'll give you, or we will come up with a row operation. When I see this capital R2, what do you think that stands for? Row 2. So that means in my matrix, I am going to change row 2. So row 1 is not changing. Okay? But I am going to replace the second row with something. And here's what I replace it with. Negative 3 R1 plus R2. What do you think that means? Negative 3 times the first row plus the second one. So let's kind of go through each of these numbers. So for this first entry, I do negative 3 times, what's the number in row 1? 1 plus the number in row 2.
0.
Yep, and you get 0. So for the second number, so I'm basically using this column. So I do negative 3 times the number in row 1, which is a negative 2, plus the number in row 2. So what do we get? 1. Third one. So negative 3 times the number in row 1 plus the number in row 2.
Wait, plus what number?
The corresponding.
Yeah, you work in that column. If you don't like writing it out like that, especially when you're first doing these, as you do more, you probably won't have to write out as much, but if you're getting confused, you could just say, okay, negative 3 times row 1. So if I took that first row times negative 3, you get negative 3, 6, and negative 6, right? And this was row 2. So when you add those together, negative 3 plus 3 is 0. 6 plus negative 5 is 1. Negative 6 plus 9 is 3. So that's where it came from. Alright?
Sure. I sounds bad. Just okay. What?
Okay, let's do another one.
So, row 2 stays.
Well,
No, row 2 changes.
whatever row it's equal to is the row we're changing. So we're going to change row 2. So, the row you are not changing stays the same.
Are we trying this one on our own?
Sure.
Hopefully these are good.
Okay, so row 2 equals -2 times the number in row 1, so that was a 1, plus the number in row 2. So we get 0. Alright, next one. So it'll be -2 times a -3 plus a -5. So you get 6 plus -5, which is 1. Okay, last one. -2 times the number in row 1 plus the number in row 2. So you get 4 plus 5 is 9. Alright, do we need to do another one like this? Okay. Let's see if we can come up with our own row operation. So, you need to find a row operation that will result in the augmented matrix having a 0 in row 1, column 2. So row 1, column 2 is this number. I need that to be 0. So which row am I changing? Row 1. Typically we write that with a capital R just to kind of make it stand out. That's the row we are replacing. Okay. How would you do that? So think about elimination for a second. Okay, if you had x minus 2y equals 2 and y equals 3. If I wanted to eliminate, what would you do to the second equation? Multiply it by 2 and then you would add them together, right? So we are going to do the second row times 2. So 2 row 2. And then I have to add it together. So plus row 1. Let's see what we get. So when I do this, the second row didn't change. The first row. I'm going to take the second row times 2 and then add it to the first. So that would be like 2 times 0 plus 1, which is 1. 2 times 1 plus -2. 2 times 3 plus 2. Is that okay? Let's do another one like that. I'm going to give you one to try on your own. All right.
Oh, see?
Okay. And I want to get a 0 in row 1, column 2.
Oh, word.
Okay.
I said row 2. We didn't do it, but I'm on calculator.
So we need this number to be 0. So which row are we changing? We're going to change row 1, replace row 1. Alright, so think about elimination. If you wanted to eliminate that, what would you do to the second row? So -5 times row 2, and then you would add it to row 1. There are different ways you might have written that. You could say row 1 minus 5 R2. That's equivalent. So we are replacing that first row. Okay, so it's saying -5 times the number in row 2 plus the number in row 1. So the first one is, second one, -5 times the number in row 2 plus the number in row 1. -5 times the number in row 2 plus the number in row 1. -5 times the number in row 2 plus the number in row 1. Are we okay with that one? Alright, so we're going to talk about how to use this matrix to actually solve a system. And I might do one example if we have time, and then we'll stop for today. Okay? So our process, we have to do this in a very specific order, because otherwise if you start in the wrong spot, your later steps will undo the work that you did, and it'll make your problem a lot longer than it has to be. So, the Gauss-Jordan method, it's how we use a matrix to solve a system. We have to go in a certain order. So the first step is get a 1 in row 1, column 1. So if you think about a matrix, we're going to get the 1 here first. Second step is to get 0 for all other column 1 entries. So everything else in the first column has to be a 0. Then we move to the second column. And we want to get a 1 in row 2, column 2. What do you think the next step will be? Get those to be zeros. All right, what do you think the next step would be?
You just go on like
Yeah. So the next one would have to be in row 3, column 3, and then 0 for everything else in column 3. And when you have it set up like this, can you look at this and tell me the solution?
Yeah.
Because this first equation would say,
X
Or
equals
x
2.
equals 2, y equals -4, z equals 5.
okay, so our goal is to get 1s on the diagonal and 0s everywhere else. So then, alright, you have to start and work your way over, so you have to start in column 1. You also want to make sure you get your 1 before you get your 0s. Okay, if you don't go in the right order, then you'll have to end up adding rows together to get a 0, and it will undo something else that you've done.
What we're gonna do is write those little equations to make each row
Mhm.
little
Yeah. So let's try, we'll just do 1 together today, and then this is our stopping point. And then Monday we will pick up with more practice with these. So if I told you to solve this system, now yes, I know you could solve this very quickly using substitution or elimination. Okay, like I explained at the beginning, this method is longer for 2 equations, but if I gave you 4, 5, 6, 7, it's a much faster way. So just be patient with me. You don't want to start off solving a system of 6 equations. Okay, this has a time and place, just not on the problems we're using to learn it. So if you wrote your matrix, what would your first row be? 3, -4 equals 1. 5, 2 equals 19. Okay. The other thing I want to stress, there are multiple ways of doing these problems. Okay, what do I need first? Okay, this number has to be a 1. So you can't just like write a new matrix, you have to write a row operation for me. So I'm changing the first row, so I have to figure out how I'm going to change it. You get points for this, for telling me what you did. And when I get this new matrix, we didn't change the second row, so it's going to be the same for the moment. All right, so can you think of any options for getting this 3 to turn into a 1? Okay, you can multiply by a third. That option always works. Multiplying by the reciprocal will get you a 1 every single time. So if you don't have another option, do that. Yes, it'll give you fractions, but you have a calculator, you can handle fractions, so that would work. Is there another option that comes to mind?
Maybe, could you distribute an exponent?
Well, we can multiply it by something, and we can add rows, or subtract rows.
Simply fractions.
You have 5, you could do.
Get a 0. What would happen if I took this row times 2? What would that turn into? 6. And then how could you get a 1? Subtract the second row. So would that be an option?
Yeah.
Yeah.
I like that better.
Oh,
I
that
like
makes
that.
sense.
So different ways. You guys might start in 2 completely different ways, and that's okay. Which way do you want to go with?
Two.
Okay. So we are going to take
2.
row 1 times 2, so 2 row 1, and then we are going to subtract row 2. Now you're welcome to grab a calculator and do these calculations if you need to, if your numbers get ugly or anything. So we're doing 2 times the row 1 number, whoops, not minus 5. I said row 2 and then I wrote 5. Minus the row 2 number, which was a 5. So 6 minus 5 is 1. Move along. So the next one. So 2 times -4 minus my row 2 number, and we get last one. 2 times my row 1 minus my row 2. Bless you.
-17.
We have our 1. What's the next thing we need?
Zero.
So this 5 has to be a 0. We have to finish column 1 before we move on. So which row am I changing? Now, how would I get that to be a 0? You can't take a whole row times 0. You'd have to take first row times -5, and then add them together. Not changing the first row. Alright, so -5 times 1 plus 5.
Can we go ahead and put 0? Or is that?
Hmm.
Can we go ahead and put 0 in all of them?
Only if they all turn into 0.
What won't that do?
So -5 times the second, so times row 1 is -10 plus row 2, so we get -48.
Would it be positive? Negative times negative?
Oh, yes.
it would be.
Thank you, I messed up. I couldn't read my own writing. So what would that be then? We would have 52. Okay. -5 times row 1, so times -17 plus 19.
104.
Column 1 is done. So now what do we need?
Get a 1 with column 2.
Okay. Row 2, column 2 has to be a 1. What's an easy way that would always give me a 1? So just multiply by the reciprocal. So I didn't change the first one. 0 times 1 over 52. 52 times 1 over 52. 104 times 1 over 52.
2.
Alright. Then we have one more step. What do we need now? This has to be a 0. So we're going to change row 1. So we have to take 10 times row 2 to get a positive 10 and then add it to row 1. Okay. So row 2 isn't changing. So 10 times 0 plus 1. 10 times 1 plus negative 10. 10 times 2 plus negative 17.
3.
So what's my solution?
X equals 3, y equals 2.
Do we order pairs?
So 3, 2 is the solution. And that's where we're stopping for today. We will practice this on Monday. There